You type a question, the AI generates a response, and the interaction ends. For summarizing text or answering trivia, this single-pass system works perfectly. But the moment you ask the software to do something, it hits a wall. Imagine giving a conversational AI a specific real-world objective. Find the 3 cheapest flights to Tokyo next month, check if your loyalty points cover the cost, and book the best option. The system will fail. It can provide a highly detailed step-by-step guide on how to book those flights yourself, but it cannot execute a single step of that process on your behalf. The issue is architectural. A standard chatbot processes your prompt in isolation. It has no built-in mechanism to query a live database, store the result of that query in its memory, and then make a secondary decision based on what it just learned. Solving this requires a shift in software design. Developers have to move away from a linear, one-time response model and embed the language model inside a continuous loop. The intelligence to understand complex problems is already present in these models. The barrier to building autonomous software isn't the brain of the AI, but the lack of an architecture to sustain action over time. This architecture is built on the React framework, the continuous interleaving of reasoning and acting. Instead of generating text and stopping, the model alternates between thinking about its next move and interacting with external tools. We can see the mechanics in these 5 stages. The agent perceives a prompt. It uses a language model to reason through the problem. It formulates a plan. It acts by triggering a tool or an API. And finally, it observes the outcome of that action. That observation becomes the new input. The agent reads the result, figures out what information it still needs, and repeats the cycle until the objective is reached. By chaining these steps together, you turn a passive text generator into an active digital worker. It can break down a messy, multi-step problem and solve it piece by piece. Let's track that Tokyo flight request through the loop. In iteration 1, the agent reasons that it cannot book a flight without knowing the current prices. It acts by generating a search query and calls an external airline API. During the observe phase, the agent pulls that pricing data back into its active memory. Moving into iteration 2, the agent reviews its progress. It has the prices, but its original instructions require checking loyalty points, so it acts again, this time querying the user's private account database. Now in iteration 3, the system has all the pieces. It mathematically compares the flight costs against the retrieved point balance and acts by executing the final booking sequence. Once the agent observes the confirmation code from the airline, it hits its programmed stopping condition. It exits the loop and hands the finished itinerary back to the user. 3 complete cycles, 3 different external tools. A complex task, started and finished by a machine operating entirely on its own logic. Traditional software runs on deterministic if-then rules. A human engineer must hard-code the path forward. Agentic software is probabilistic. You define the goal, and the system dynamically calculates the best route in real time, adapting when a tool fails. This creates a significant shift in capital efficiency. Solo founders are now launching companies that operate with 10 to 50 times the leverage of a traditional firm, using these loops to replace entire operational departments. For complex projects, developers deploy multi-agent crews. A primary orchestrator agent breaks down a high-level goal, assigns subtasks to specialized worker agents, and synthesizes their output. Software has transitioned from a tool that waits for a command into a digital employee that follows an objective. But autonomy carries risk. If a website changes its code and an agent search tool returns an error, the agent might decide to retry indefinitely. Without a hard stopping condition, it enters a runaway loop and burns through server costs in minutes. Building these systems for production requires strict observability. Engineers log every reasoning step and tool call while setting hard-coded limits on token budgets to prevent infinite recursion. For high-stakes workflows like financial compliance or medical routing, organizations keep humans in the loop to review the agent's proposed plan before it's allowed to execute the final action. By embedding language models into these looping architectures, AI has moved beyond conversational interfaces to become an autonomous reasoning engine embedded in our